All right. Just a reminder, we are being recorded. So.
Third period physics, honors physical story.
Oh, that's what happens when I'm recording. It flashes to let it know that it's recording. Anyway. All right. Our plan for today. Not recording class, so you can talk the whole time.
I don't know why I like to do that.
All right. Our plan for today looks like this. I wanted to go through the calendar from when we started this unit so that you know everything that's coming up as far as preparing for the test and stuff like that. If you have questions at the end, if you want to talk to me about the test itself, what you should be expecting, what you should be looking for, we can do that as well. But I wanted to make sure we went through everything so you at least know what to look for. Hopefully you started doing stuff already, but if you need a little more focused attention in one area, here we go. Starts. Objective sheets, right? Unit 9, chemical reactions, equations, and stoichiometry. And there it is. Hopefully you've had a chance to look at it. Hopefully you've had a chance to start going through stuff. But if you haven't, we'll get you through it today. Okay? All right, we'll keep this out for reference. And let's go back here. We'll go to the calendar. This unit started all the way back on January 30th.
Wow.
Thanks. So it's a long unit. We did a lot of stuff. Pretty close to a month, yes. The first thing that we did in this unit dealt with balancing equations, or equations, then balancing equations. Okay. You have an outline as far as balancing equations goes. We talked about what you needed to do to balance an equation, what an equation was, how we balanced it, why it has to be balanced, coefficients, subscripts, that kind of stuff. The first problem set that I gave you looked like, hopefully it will come up here in a second. The first problem set that I gave you in this unit looked like come on. Looked like this, essentially. So, there we go. So there's the first problem set that I gave you. It says balancing chemical equations on it. Right? Looks like this. Okay. On the calendar, on Tuesday, January 31st, there's a link there that says problem set answers. That's where you'll find the answers to this. Okay? Good there? Next thing we did the lab where we had the models, where we had the little blocks, and a lot of you didn't use the blocks to make the models, and you made robots and whatever, and that's fine, okay? But that was another example of balancing equation stuff. Then, what? Oh yeah, you guys were, that's the day before we were here for a while. Then, on Friday of that week, Friday, February 3rd, you took your first quiz for this section. And that quiz has been handed back to you, and it looks like this.
Oh, that's funny.
It says formulas and equations quiz up at the top. It had a couple of equations. It had a couple of subscripts on it. Blah blah blah. You had to balance a few things and stuff like that. Okay. So that was your first quiz. Okay. Good so far. Next thing we did, types of reactions. As far as the notes go for types of reactions, that was the one. It was just a single sheet that had the star on it, right? And each point of the star represented a different kind of reaction. As far as practice goes, on the back of this sheet, you had this sheet. It says classifying reaction types. So this was also a practice for balancing, but also classifying those different reactions as single replacement, double replacement, whatever. The answers to this problem set are posted online Friday, February 3rd. Okay, so it says classifying reaction types problem set. The answers are there.
Where can you get that? Like specifying reaction types?
Oh,
Can you like print it out?
No, I said it should be. Sam, it's a problem set that I gave you. This was on one side, and then that was on the other side. So it was a double-sided sheet. Those two were together.
Okay.
All right, good there. Then Monday, February 6th, Tuesday, February 7th. We went through a couple of things kind of quickly. If we go through things kind of quickly in class, that means how important are they in the big picture of the test? Probably not real important, okay? Not that they won't be on the test, but they're not going to...
questions at the most.
I don't know about two derives. I don't want to like... Yeah, a few. I don't want to lock myself into there's only going to be, but, there's not going to be as many questions about these things as like balancing equations, classifying reactions, that
Where
kind
are you
of
still going?
stuff. We did a lot of stuff. Yeah. So, Monday, February 6th, we talked about acids and bases. There was an outline that goes along with it, and we talked about what makes something an acid, what makes something a base. We talked about pH, and then we talked about neutralization reactions. Okay? On Tuesday, February 7th, we talked about reaction energy and reaction rates. You had an outline that said reaction energy and reaction rates. Okay? We spent a good amount of time talking about that picture, right? Does that look familiar?
Oh.
Okay. And then we talked about like how this is an exothermic reaction and how we can tell that because of where it starts energy-wise and where it ends. And then we talked about like this, which is still an exothermic reaction, but it's not quite as likely to happen because of there's not as big of a difference between the energy of the reactants and the energy of the products. And then we talked about like this, right? That was an endothermic reaction because the reactants start down here and the product starts down here. We spent time talking about those graphs, okay? And then, in addition to those things, we talked about stuff like how temperature affects the rate of reaction and the particle sizes and stuff like that, okay?
Where's that graphic? What's the blue line again?
Well, look. That's recording about reaction rates. Watch that. Pretty good.
Why am I computer?
Put some headphones on.
Where? I put.
I mean, if you plug your headphones in, put your headphones into your computer, right? Yep. You should be able to.
I usually get an iPhone.
There you go.
I don't have an iPhone.
What's that? Lost. Oh. All of those things, types of reactions, acids and bases, reaction rates, quiz from February 10th. That quiz looked like. Oh. That quiz looked like this. Okay. Some of us didn't do so hot on it. Okay. But we went through in class, especially the ones that a lot of people miss. Right. We talked about those different kinds of things. Why people answer certain answers and stuff like that. Yes, sir.
Just like, with
Like number 3, that was the one that a lot of people had problems with. And I don't think I put anything that was quite that confusing on the test.
so it's just gonna be like the generic A plus B plus C.
No, it'll be more, Chris, it'll kind of be more maybe like this problem set here. That I think these here are pretty more straightforward than that one that's on the quiz. So, yeah, you'll have to do basically just like this.
Wait,
Okay?
one there.
I'll give you a bunch of reactions. There's a blank line. You have to fill in what kind of reaction it is, just like on the quiz. Okay. Yes, sir.
When they're like synthesis and decomposition and stuff, do they have to be balanced?
Not necessarily.
So, like-
if I don't ask you to balance them, then you don't have to. You can just identify them. Although, Sam, I think on the test, I gave you balanced equations and said,
Because I think I confuse myself.
yeah. I think on the test I balanced them, and I just said, tell me what kind of
Okay,
reaction.
so number 6,
Yeah.
that isn't balanced.
No, it's not, but it's still a synthesis reaction. Can take it small,
Right.
make it big. Allison, go ahead.
I don't understand like number 7 like it was like a substance that each of 3 has.
But Allison, let me go through the rest of the stuff about the test so we can come back with questions. All right, moving on. That same week, we did the types of chemical reactions lab. That's the one that you wrote your lab report on. So that means that we're probably going to see a good portion of that kind of stuff. What kind of reaction is this? What kind of reaction is that? Because we spent a lot of time on it in class. Okay. Then, starting on Monday, February 13th, is when we started into the stoichiometry ideas. We started off talking about formula mass. And we did this problem set mostly together in class. Not that one. Yeah. Sorry. We did come on. Yeah, it's
Under pressure. Feel sorry.
there we go. This one in class, okay, where I gave you the formulas up at the top of the page, and then at the bottom of the front page you had to do the formula masses, okay? And then on the back of that page, there were a bunch of conversions, converting between moles and grams and formula units and stuff like that. That was the first part of our introduction to stoichiometry. On Monday, February 13th, the answers to that problem set that I just showed you are posted. Then, starting on Tuesday, February 14th, was when we started getting into our stoichiometry stuff. As far as the stoichiometry things are concerned, there are 4 sheets that you should have. One is the set of slides, the set of blank PowerPoint slides, where we did an example of one of each of the 3 kinds. Then, there should be 3 problem sets. One says mole to mole relationships. One says mass to mole relationships. One says mass to mass relationships. Okay?
I have done this.
I just wanted to show for the record, since how we are recording class, Sarah Schwartzer gives you the keys to this office. If anything comes up missing, Sarah Schwartzer's responsibility.
Thanks.
With 24 witnesses. Alright. So then we get into the stoichiometry stuff. We spent a good portion of the next week talking about stoichiometry problems. Talking about mole ratio and how we get the mole ratio, and how if we start with something in grams, we have to convert it into moles first before we can compare it to different parts of the equation, etc., etc. Answers to all of those problem sets that I've given you are all posted online. And so you can check out the answers to the 3 problem sets dealing with stoichiometry problems that I have given to you.
That's true. Nothing missing.
You too. Alright. Then, yesterday we talked about percent yield. Okay? We spent basically half of one period talking about percent yield. Okay? There's a test tomorrow, right? Well, we spent half of one period talking about percent yield. How much percent yield stuff do you think is going to be on the test?
Oh, it probably shouldn't be on the test if you only spent half the period.
Well, it should be. Yeah, it'll probably be like 25 points.
How much should I come in during study?
I think. I mean, I haven't added it up totally yet, but it's like in the 40s. So,
Wow.
I mean, this started back on January 30th, so it's a long chunk of class.
So, there's a lot to know.
It's a lot. Yeah. I tried to warn you about that last week when I posted the objective sheet. All right. Yes.
Yes.
Questions. Allison, go ahead.
Okay, well, I have two.
Okay.
One of them is, I know you said that the percent, oh, well, we can start with this
Okay.
one. Okay, yeah, I don't get it. Number 7.
I thought you talk about 2 problems on this quiz.
Hey, that
Because
was in the book. Remember, that was like the day I did my homework, and then I got 6, and then I forgot the notes in my book.
okay. So Allison, for number 7, pH. We talked about the pH scale in class. pH is a scale that runs from 0 to 14. 7, it measures how acidic something is.
Yeah.
7 is a substance that is completely neutral. It's neither acidic nor basic. Okay? Pure distilled water is a 7 pH. Okay? It's not acidic or basic. The farther you get away from 7, either the more acidic or the more basic it gets. Acids have lower pHs. So as you start getting into anything below 7 is an acid, but something that has a pH of 3 is a stronger acid than something that has a pH of 5.
Okay,
Something
so
that has
as
a
you
pH
go
of
down-
1 is a stronger acid than a pH of 3.
Oh, so as you go down, like down from 7, it's more acidic.
Right.
And if you go more up, like let's say like 14 is the most basic.
14 is the strongest base that's out there.
Okay.
And Allison, we said that relates to how much of this is in that solution, how much of those hydronium ions. The more hydronium ions you have, the more acidic it is. So as the pH goes down, the number of those hydronium ions goes up.
Yeah, because they're more acidic.
Yep. So that's number 7.
Okay.
Okay, that's like the same question, but so on the objective sheet, that would be comparing the relative strengths. like,
Yes.
farther away from 7.
Exactly. So yeah, where are we here? I thought I pulled up the. Oh, I think I closed the objective. But yeah,
It's on number 8 on the objective.
let me pull it up. This I wanted to have it up anyway. I think I closed it by accident.
Would have been stronger, so yes.
Yeah. So number 8. Compare the relative strengths of acids and bases based on their pH values. That's
The lower
exactly.
number is better.
Lower number. Well, the lower number means it's more
So
acidic.
you want, oh
So
yeah.
what number would you wear, Fudge?
You're talking like, well, your stomach has a pH of about 1.5 or so, okay, inside of your stomach. Now the inside of your stomach has a nice lining on it so that it doesn't eat away your stomach, okay? But, like, glad we're getting this on recording, right? But when you vomit, okay, all those things that should be in that nice protectively lined stomach is now up here, right? And that's not good, and that's why it hurts when you. That's why you.
Acid reflux.
Acid reflux means that that acid that should be in your stomach is now coming up into your esophagus. One of the things that can happen with acid reflux is you can start getting like ulcers in your esophagus because your esophagus isn't lined to contain that acid.
My baby cousin has like.
I don't know if you die from it, it just hurts.
Be like.
I mean, I suppose if it ate a hole in your esophagus, that would be a problem. But yeah, so Chris, if you throw up, will it eat your skin? Not necessarily, but but if you got into like in like those zeros and it depends on that kind of stuff. Yeah,
Then there'd be negative.
it's all to depend. Nope, zeros the lowest. That's good.
So, can I do a different topic now?
Actually, hold on one second.
Yeah.
Awesome. On that same quiz, I did want to talk about number 8 a little bit because it is a problem that a lot of people have. Okay? Number 8 is asking you about a neutralization reaction, which I think, Caroline, do you have your objective sheet out still?
Yeah.
Okay. It's,
Oh,
it's number 9 about
Yeah.
neutralization reactions. Okay. So, number 9 on your objective sheet talks about neutralization reactions. Neutralization reactions are reactions between acids and bases, but they're just double replacement reactions. Okay? If we take a look at the reactants for this reaction, here they are. Oop. The one on the left, HNO3, that's going to be your acid. I know that because it has an H in front of it, okay? Which I think, Caroline, might be is it number 6 or number 7 says identify an acid from its formula or something like that?
And identify it from its formula.
Okay.
Oh, okay, sorry, yeah.
This is going to be
5 and 6.
this is going to be your acid because it has an H in front of it. That's what identifies it. It generally thinks it's an acid.
It's always
Pretty much.
every time it's acid.
I won't say every time, but pretty much.
What number is that? For
5 and
acid.
6.
Acid is 5.
So how is
So
that in
what-
our
how
notes?
we
That if the H in front of it?
It's in our book too.
Oh, yeah.
The
It's on the
base-
acid side.
Well, any formula that has an H in front of it is going to be an acid. Generally. Any formula that has the OH at the end of it is going to be a base. So in this case, this is going to be your base. The calcium hydroxide is going to be your base because it has the OH in it.
Is that every time? Like no matter?
Like I said,
On the
let's go generally. For the test, yes, that's going to be
Okay,
assumption.
that's, yeah, but I don't.
But yeah, I don't want you to yell at me when you go to chemistry and you learn something different.
I don't.
Because
What if the OH was in front of the element?
won't be there because OH is a negative. It's a negative anion,
Oh.
and so that's always going to be at the end. Okay, go ahead.
So does that like the end up being CA would be?
Neutralization reactions, right? We trade the front and the back. Okay, so H is the front of this one. OH is the back of this one. When you put those together, what do you get? H2O, right? Neutralization reaction, one of your products is always going to be water because the front of the acid and the back of the base come together to make HOH, which is H2O. Then, Miriam, like you said, now it's just a matter of the front of this one and the back of this one have to get together to make the other product of the double replacement reaction. So if we go back to our choices, you should be able to get rid of B and C immediately because what do B and C not contain as far as products are concerned? There is no water in B or C.
On this example, what about the two stuff?
That's just balancing out charges, okay? Remember we said, like us, we talked about, if you have this, right, that doesn't mean your product's going to be MgO2 just because that 2 was there, right? It has to do with balancing out charges and stuff like that, okay? So that's, that's not necessarily the case. Okay? But here in this problem, right, A has to be the right answer because it's the only one that takes the front of the base and the back of the acid and puts them together for the other products. Good.
Why would you keep that 2 for the end of the...
That has to do with the fact that calcium has a +2 charge, or it's looking to lose 2 electrons, but that nitrate group only has a -1 charge, so it can only take on 1 electron. So in order for the calcium to be balanced, it has to have 2 nitrates. Just like, if you talk about calcium and chlorine, right? Chlorine can only take on 1 electron, and calcium has 2 to give, so it needs to have 2 chlorines to balance it out. Same thing, just, but that doesn't, that's just, I will give you those formulas on the test. You just have to recognize the front of one and the back of the other one. Okay? Alright. Alex, do you want to change gears?
Yeah.
Okay, what do you want to do about next?
Mass relation.
Okay.
So what you, I just want to see if I'm right on this. So
Okay.
what you do is you would take the original elements and you would take the mass that they give you,
Mhm.
and then Einstein fraction bar, and then you put the same element on the bottoms of with grams, and after that, what you write how much it is on the periodic table.
Mhm.
So if it was like silver, it would be the grams of silver of the. Okay. And on top it would be the. On top would be the element you're trying to change to. What would be
No, not first. Okay, that's not your first conversion factor. So, you were asking me about this before, right? I told you yesterday in class that number 2 is a mass-mass problem. Okay? From your data table, you should be able to give me some grams of magnesium that you started with. Okay? for a mass problem, the first thing we have to do is convert that into moles. That's always going to be 1 mole because then, Kenny, where are we going to get this grams number from? Next, because Kennedy, that's what you started with. It said, calculate the theoretical yield of the product based on the measured amount of magnesium reacted. Or in a problem on a test, I give you, this many grams of magnesium react with oxygen to form magnesium oxide. How many grams of magnesium oxide are produced? Right? So you need to figure that out from the problem too.
Just to figure out the formula from the problem.
No, you have to figure out what conversions you have to do from the problem. Okay?
So at the bottom of on the denominator for the grams of magnesium, that would be what it is on the periodic table.
Yes. For this first conversion factor, Kennedy, like you said, this is always going to be 1 mole, and then this is going to be number from the periodic table. This one happens to be 24.31.
And that's from the coefficient.
Then for the next one, I'm going to get
mole.
then the next one, moles of magnesium on the bottom, moles of magnesium oxide on the top. And Sam, we call that our what?
Mole ratio.
That's our mole ratio. We get these numbers from our balanced equation, coefficients. And then the last one in a mass problem, I'm going to put moles of magnesium oxide on the bottom, and then grams of magnesium oxide on the top. Okay? Now, Kennedy, in the green conversion factor, right, what number goes on the bottom of this green conversion factor? 1 mole here. That's in the periodic table, and you have to add the 2 of them together. Okay? So this is a specific mass problem for this lab, but any mass problem, you have to go through this process. First, change the mass you were given into moles. That's the blue conversion factor. Then go moles to moles from the balanced equation. That's the red one. That's our mole ratio. And then the green one converts the moles of the new substance into grams of that new substance.
And with the moles, that's the only time you're worried about coefficients.
With the mole ratio, that's the only time you're worried about the coefficient. Okay? Just go ahead.
So does the coefficient go on top or?
It goes with whatever formula is here, right? So here on the top of, for this one, what number is going to go on the top of this 2? Because that's the coefficient in front of magnesium oxide. And then what's going to go on the bottom of this one? This is going to be 2 as well, because that's the coefficient that's in front of magnesium. In this one, it just happens to be 2 to 2, just coincidence from what our equation is. Okay. Does that make sense?
How many grams of
No.
MgO?
MgO.
Oh, so
Yeah,
that's
so you have to add 2. It's like 40.
It's like 40, sorry.
Allison, go ahead.
I have 2 questions.
Good.
One was like with the previous thing where you said that like the H it was the acid and whatever. With the 2 in the middle, like, does that mean that they're always together in a double replacement? Like when you're like for the product side,
Yes.
are always going to be together.
Yep, because that's the key to a double replacement, right? We go the front of one and the back of another one, and then the front and the back of the remaining front and the back.
Oh, okay. And
It just so happens when you're talking about acids and bases, like in this picture, right? The 2 yellows, the front of the first compound, the acid, is an H, and the back of the base is an OH. So when you get those 2 together, it always makes water. For a neutralization reaction, one of our products is water. That's just because that's how the double replacement works in this
did
case.
it tell you there was double replacement?
Yep.
Oh.
In your notes it says that. So.
Oh, okay. And then I have a question about the percentage yield thing. You said that like we're not doing a lot.
Yeah.
But should we know, like, if you give us this paper, should we like
Probably not even 1 or 2 problems, Ron. Probably like I might make it like a multiple choice question.
So should we not know? Because
I
I've
mean,
never done
if
it.
you can do problem 1 on that page, all right? The percent yield problem set that I gave you yesterday. Okay. If you can do problem 1, that's plenty. That would be
So
plenty.
for that, we want to find theoretical, actual, and
So
pretend.
actual, I'm gonna have to give to you. Okay.
Do you think that was here?
Yeah. And it says, doesn't it say like, or here? So just so people know what we're talking about.
You put those into
I had a video posted, but there was a problem with the video, so I had to take it down. But I might.
Was I?
No, that was it.
Oh, that was good. Yeah.
So Allison, in number 1, right? In 1A, it says in one process, 8.87 grams of arsenic oxide, okay, is reacted, and it says 5.33 grams of arsenic is produced.
Yeah.
That's the actual yield, because I'm telling you, that's how much I made. Okay? This one, the 8.87, that's the one you're going to use to do the mass to mass. That's not the theoretical yield. That's how much of one of the reactants you started with. You're going to do a mass to mass stoichiometry problem to find out how much arsenic you should have made.
So then you have to make up the, like, find out, like, mass to mass, whatever, and then solve it for the theoretical thing.
Yeah. Basically, Allison, we talked yesterday that the theoretical yield is basically a mass-to-mass stoichiometry problem,
Every time.
pretty much.
Oh.
For your purposes of this test, we'll go yes.
But, like, the thing that I don't get is I don't really get how to, like, teach those math tests. I don't get how to start off, like, the times, sign, fraction, everything, you know, just those problems.
Okay. So,
How?
this, for problem number 1, right? On that problem set. They gave you this, right? So you're starting with grams of arsenic oxide. Come see me if you have questions. I'll finish this up so you can look at it if you want to. Yep. Yep. It would be a theoretical and the, yeah. Your theoretical and your actual. I'm not worried about what the actual number is. I'm just worried about going through the process.
And she said she said
That's not even
You're like, it's your birthday? Yeah.
Happy birthday!
I thought I was singing happy birthday.
We started with a real small amount.
I wish I could go. I'd rather do that, but I did this myself.